The question says, copper will completely react with oxygen in the air to form copper 2 oxide. How many grams of copper 2 oxide would be produced if 5.61 grams of copper reacted completely? Assume there is ample oxygen available to react. Here's our chemical equation. Copper plus oxygen reacts to form copper oxide. The question is asking us to calculate how many grams of copper 2 oxide would be produced. So here's my copper oxide. So we've been asked to work out how many grams of copper oxide will be produced. So X representing my unknown. If 5.61 grams of copper reacted completely. So here's my copper, and I have 5.61 grams. Assume there is ample oxygen available to react. So here's my oxygen. I'm not going to use the word ample. I'm going to use the word excess. Now, what does excess mean? In this instance, it means that I have so much oxygen present that all of this copper is going to be able to react and form copper oxide. All 5.61 grams will react to form copper oxide. So because we've been asked to calculate an unknown, this is a stoichiometry question. What are the rules or steps for calculations involving stoichiometry? Determine the chemical equation, make sure the reaction is balanced. Always work in moles. Any other unit, e.g. grams, kilograms, must always be converted to moles. Use a molar ratio determined by considering coefficients in the chemical equation to calculate the amount of the unknown. So step 1 says, determine the chemical equation, make sure the equation is balanced. We're given a chemical equation. Is it balanced? 1 copper, 1 copper on the left-hand side, 1 copper on the right-hand side. 2 oxygens on the left-hand side, 1 oxygen on the right-hand side. I need to double the number of oxygens on the right-hand side. So now I've got 2 oxygens on the right-hand side, 2 oxygens on the left-hand side. By putting that 2 there, I've also doubled the number of coppers. So I've now got 2 coppers on the right-hand side and 1 copper on the left-hand side. So I'll double the number of coppers on the left-hand side. So now I've got 2 coppers on both sides, 2 oxygens on both sides. Great. So that's step 1 complete. Step 2, always work in moles. Any other units, e.g. kilograms, grams, must always be converted to moles. We're working at the moment in grams. Our answer, they want it in grams. Now, we still can't work in grams though. We're given 5.61 grams here and we are asked for our answer in grams. We need to work in moles. So I need to convert 5.61 grams of copper into moles. So the equation to convert grams to moles is N equals M over M. Now to make sure I'm clear as to the fact that I'm calculating the number of moles of copper, I'm going to write little subscript Cu beside the N to indicate that I'm working out the number of moles of copper. The number of moles is equal to the mass divided by the molar mass. Number of moles therefore is equal to 5.61 grams divided by the molar mass of copper. So the molar mass of copper so there's copper right there. The molar mass of copper is 63.55. By 63.55 grams per mole. And that is equal to, let's go to our calculator, 5.61 divided by 63.55. That's equal to 0.0882769472856. So quite a long number. So what I'm going to do, I'm going to use all of these values here in my working out, but I'm only going to write in some of them into my actual equation or into my actual question. Great, so that's the number of moles of copper that I have. Step 2 is complete. Step 3 says use a molar ratio determined by considering the coefficients in the balanced chemical equation to calculate the amount of the unknown. So if I go back to my balanced chemical equation, I can see that for every 2 molecules of copper, they react with 1 molecule of oxygen to form 2 molecules of copper oxide. This here is my molar ratio. So I can use this molar ratio to work out the number of moles of copper oxide produced. It's every 2 mole of copper, so 2 mole of copper forms 2 mole of copper oxide. I rule off underneath, or I draw a line underneath. If I have 0.088276 mole of copper, how many mole of copper oxide will I produce? Great, so now I can solve this by cross multiplying. So how am I going to cross multiply? I'm going to multiply the numerator of one side by the denominator of the other. And I could rearrange this and solve for x if I wanted to. What I'm going to do here is recognize that for every 2 mole of copper, I produce 2 mole of copper oxide. These values here are equal, therefore these values here will also be equal. Therefore, x will be equal to 0.088276 mole of copper oxide. So therefore, again, just to go through that one more time, if I have 2 moles of copper forming 2 moles of copper oxide, if I have this many moles of copper, I'm going to form the same number of moles of copper oxide. Now, are we finished? Because we have worked out an amount of copper oxide. Well, no, we're not, because the question says how many grams of copper oxide will be produced. So we need to now convert this number of moles back into grams. And so we use the same equation, which is N equals M over M. And I'm going to indicate that I'm solving for the amount of copper oxide. So the mass of copper oxide. And so now I substitute my known values in. So the number of moles is 0.088276 is equal to the mass, which I'm going to write as X, divided by the molar mass of copper oxide. And so the molar mass of copper oxide, we go to our periodic table. Copper's 63.55 and oxygen is 16. So 63.55 plus 16. And now I'm going to solve for x. So I go back to my calculator. I'm going to use this whole value up the top here to improve my accuracy. So I'm going to say 0.882769472856 times, in brackets, 63.55 plus 16 is equal to 7.022431.15657. So x is equal to 7.022 grams. So why have I left it at 7.02? This is my final answer, it's in grams. I've considered the number of significant figures. Now, why is it left to 3 significant figures? Well, because the smallest number of significant figures I have anywhere in this equation is found right here in my initial value, 5.61 grams of copper. So there's 3 significant figures. So my answer is also going to have 3 significant figures. So 7.02 grams. And I'm going to underline that answer.